All right, man. So, Going Native, we are what, episode 5?
5.
Wow, dude. Nice job, man.
I can't believe we could last so long.
I agree. We're even kind of matching. That's pretty weird, man.
Yes.
Now, listen. You met a fellow Latino who works on the C++ team from Puerto Rico. Tell me a little bit about this guy. We're going to go talk to him today.
Sure.
And this episode is about the visual in Visual C++. And that, of course, is the IDE.
Absolutely.
And IntelliSense and stuff. So.
Yes, so Raul, is a friend of mine. He's working in quality assurance in the Visual C++ team. Mm-hmm. So we have a bowling game, last week with some colleagues. And we were talking, and I told about, this job we are doing here in Channel 9. Yeah. So he was interested in talking. So I tell me a little bit more about the feature area you are focused as a quality assurance guy. Mm-hmm. So he was talking that he was mostly focused on an aspect that has to do with compiling code, but compiling not in order to produce, the machine code that is required in order to run C++ program natively, but mostly compiling code in order to prepare some information, let's say for IntelliSense, for coloring, for everything that is happening in the IDE that makes part of the developer experience, So
totally.
So
the very front end.
Absolutely. So he has a lot of great and interesting stories to tell, So
let's see.
So it would be a great opportunity for us if we go to his office now and we interview him.
Let's do it.
Great.
You better watch out, Raul. All right. So we are with Raul. How do you say your name?
Raul.
Raul. Where are you from, man?
From Puerto Rico.
Puerto Rico. Right on. So what do you do on the C++ team?
I'm a QA in the team, which we call Software Development Engineering Test.
Okay.
But for short, QAs.
QAs, quality assurance.
Yes, we write code to test the code.
Excellent, man. So one of the things I know you work on is IntelliSense, and in some sense you had mentioned productivity tools for C++ developers. So in other words, the visual in Visual C++. This is where you spend most of your time. You also mentioned you work with Boris and JP. So let's talk a little bit about the visual side of the C++ experience. So when I buy Visual C++, I buy it in large part because of the IDE. Now your compiler is great, your debugger is great. Talk to me about IntelliSense, man.
Well, there's the important thing about the compiler that people don't really know is that yes, the compiler is the part that builds your code. A bunch of the IDE-related features, all the productivity stuff, it's related to, it depends on the front end as well. So the front end doesn't really just build your code. Like all the stuff that you actually see popping in your face, in one way or another, it's mostly related to the front end as well.
Understood. So when you type in and you hit dot or arrow, and you get this list of things to come, that's the front end compiler that's doing some work.
Right. That's
and it's squiggly lines is because it found that you had done something wrong. It wouldn't have known that if it didn't compile it.
Exactly. It's it just happens in there. Like people are not aware that we're also compiling at the same time you're doing stuff because it's not really a build per se. We're still doing some sort of building and getting that IntelliSense. And like you mentioned, those are the classic IntelliSense features. What people, when you think about IntelliSense, those are like the features you always think of. There's internally we divide them into IntelliSense and browsing. Okay. For most of our customers, most of browsing is really IntelliSense to them. Although we don't really treat them as IntelliSense here. But as I mentioned, they are all related to the front end, and in one way or another, they do depend on the front end and the compiler.
So tell me, what is it? What is IntelliSense in your definition?
Well, you mentioned a couple of the most used features of IntelliSense. You said member list when you type a dot and a list comes up with the members of we're trying to get in there, or when you do control space, which is autocomplete, which just completes your statement. You open a parenthesis in a function where you get a little tooltip saying, hey, this is the available parameters of this in the signature. That's parameter help. And when you mouse over, when you get a tooltip saying the function signature, like those are the basic 4 features of IntelliSense.
Sure.
Now, the other really important one you mentioned was squiggles. And that's important because it's always there in your face.
Yes.
Like if you screw up, well, you get red lines in saying, fix me. we don't type and think at the same time. So we start typing something, I start typing my scene, and it's like, well, I'm not done yet.
Sure.
And since you're not done yet, the compiler doesn't know you're not done yet, so it starts explaining yourself. Like you mentioned, once you're done and things are fixed, or not fixed, they're completed, then you'll know if it's really good or not.
Excellent. So now I want to bounce back and talk more about you. I mean, so you're from Puerto Rico. How long have you been on the C++ team?
I've been here for almost 4 years now.
Excellent, man. And you came right from college or from the industry?
No, I worked in Puerto Rico. I graduated 2006, I think, so I worked there for about 2 years.
Okay.
And then I came here, and I've been on the C++ team since I came to Microsoft. It's kind of a weird story, because I started in engineering. I started computer engineering.
Cool.
I actually did not enjoy the engineering part of things. I was more of a software kind of guy rather than hardware. But in the college I was at, it wasn't really that big of a distinction. So I ended up transferring to another campus where I did a mix of computer science and MSIS.
Interesting.
MIS, sorry. Management Information Systems.
Okay.
So I went to business school to finish a computer science degree. And since I went to business school, well, yes, I took C++ in there. I think I did a course of Java. And a lot of the old stuff like COBOL, Fortran, and all the old languages.
Yeah.
But at the core, I'm pretty much a C++ C# guy. That's what I've been working on for the most, even before coming here.
Excellent, man. So I wanted to ask you, like, what are some of the key things that can slow down IntelliSense or make autocomplete, slow as well? So I mean, when you do control spacebar or whatever. That's what I'm asking. So tell me, what are some of the key things that developers need to pay attention to? Because a lot of people just seem to think that, I have a big project, IntelliSense is going to be slow.
Right.
But that's not true, right?
Yeah, so one of the biggest misconceptions about that is that the slowness or responsiveness of IntelliSense, or Visual Studio in general, it's based on your project size, and that's not necessarily true. A lot of the times it's just one small construct that you can probably narrow down to a couple lines of code is what's causing the slowness, rather than having 100, 200 projects on your solution or having millions of lines of code in there. I'm not saying that that doesn't affect other things, but one of the biggest issues in there is that there's this small construct in there that's screwing everything else up. Few things that we can do to mitigate that or avoid that. One, which probably you've heard a lot about, is we advocate the use of PCH files.
Okay.
Standard headers, it makes the compiler's life easier, which in turn speeds things up, and you get more responsiveness in there. Another ones, we actually isolate those things. One of the things we have to accept is that most of the times, those things that are really slowing down are bugs in the compiler. So, yeah, we have an issue with this specific construct, and we need to fix that.
Sure.
In the meantime, what can we do to mitigate that? Well, if you can isolate that and either try writing that in a different way or putting that into an isolated file when possible. So now it's always possible. That would also help you speed things up and be more responsive and, get the full IntelliSense experience.
Sure. Now, the IntelliSense that you guys have for C++ must be different than IntelliSense for any of the other languages in the Visual Studio suite, because you have a very different build process. Now, everybody uses MS Build at this point, right? Isn't that how it works?
Including us.
Including you. But the IntelliSense story has got to be somewhat different.
It is.
Tell me a little bit about specifically the architecture of Visual C++ IntelliSense.
So we have the very specific issue that other languages don't have, that our customer base uses large projects, like really large projects as compared to other languages. So for example, C# and VB, all their IntelliSense stuff is in memory. It's, they do the design and compilation while things are happening, and they don't really have to worry that much about scalability. While we, on the other hand, our customers are more around, we have a solution with hundreds of projects, millions of lines of code, where scalability actually matters. So one of the big design changes we made during Dev 10 was, instead of having it the NCB files, they'll those cool NCBuild file that people used to delete and never liked. And hey, IntelliSense is broken, I'm just going to go delete that file and everything is fishy.
Yeah.
So we moved to a model where we have a separate process that's handling the IntelliSense stuff. It still depends on the build process and the compiler, etc. However, we do have a separate process based on your current translation unit. And let's say you have five different files open. You have 5 of those processes running. Well, you can have as many as you want. The default is 2, but you can, if you have memory, you can just keep going at them. Each one of them is doing their own IntelliSense stuff, meaning not the parsing. The parsing is going to happen at once, but like all the computations, let me go back on the parsing in a sec, but all the computations for IntelliSense and all the things that we need in real time is going to be handled by that process, which is called VC Package Server. And that's the one big different thing we do. The other one is that we do have the 2 compilers. So one's handling the build system and one handles IntelliSense.
Sure.
The one that handles IntelliSense does any kind of build.
Okay. So, you know what, I'm a visual person. And since we're talking about Visual C++, let's draw some pictures.
Absolutely.
Let's look at the architecture and the pipeline. And so when we type characters in, let's have a little picture of what really goes on.
Sure. And I'm going to go do like the whole stack of Visual Studio, not just a compiler. So
rock and roll.
If you want some more details on that, let me know.
Sure. All right, let's check this out.
So one of the things that people don't usually see about Visual Studio is that Visual Studio is just a massive piece of work which has a lot of components. And to go all the way down to IntelliSense is not just calling the compiler and displaying something. So it starts with the user typing on the editor. This request gets handled by the IDE. The IDE passes it back to the front end. And at this point, we call the external process I talked about. And it goes all the way back again where, let's say if the user is typed, let's say just mousing over. Let's say this is what the user is doing. They have their code in here, and they mouse over here. Then all the way back, they get a tooltip here saying this is the signature of the stuff you're trying to do, in the case of QI. Same thing without IntelliSense operation. The code flow is pretty much the same, just what happens at the top layer, it's, well, what's displayed to the user at the top layer is slightly different. And one thing to mention that for all the other IntelliSense language, this is pretty much the same, except that this is the VC IDE. If it was C#, C# IDE component, and then whatever they're using here. Okay. So when you're doing IntelliSense in Visual Studio, there's that common path that everyone takes.
Absolutely. Well, it is Visual Studio, right?
Right.
Talk a little bit more about this guy.
Right. So as I mentioned earlier, this is a process that is going to be doing all the, well, this is the additional compiler, which is going to be doing all the extra computations, and it's actually doing the real part of IntelliSense. Like the heart of IntelliSense is right here. This is the one that generates all the stuff and shows it to the user. Interesting part over here, like I said, it's a different compiler that's compiling stuff on request. It's not doing a full compilation of requests, of course. If I'm just doing signature on one method in here, let's say I got, and this is what I'm mousing over somewhere. I got a call to foo, and then I put my mouse over here, and I'll get a tooltip saying, this is what all this is what the user is going to see. All what's happening all the way down here is, so we're going all the way down to our compiler saying, okay, what's on this location, what's the signature of this, and then generating all that in a way that it's pretty to the user, rather than just, oh, this is random compiler code, or going all the way down maybe to assembly or stuff that people don't really care about.
Only during debug do they care about that.
First thing that happens when you load a project before any of this comes into play, although it does come into play here. So you create a new project. Let me just delete the front end part here for now. Because as I mentioned, this is the extra compiler stuff that's shared between both the IDE and the front end.
Okay.
So I'm just going to delete the front end part just to talk about your scenario right now. I added my include file in here. Well, before even that, so when you create the project for the first time, it's going to go all the way here, and the IDE is going to ask the project system, and what are the project settings, your include path, reference if there's any, et cetera, et cetera. And then it's going to create the database base of that. What that tells is, hey, I got all these include files. This is my include graph. So in the case of manage, it also has assembly references. Or in the case of Metro, WinMDs. So all that goes around the same. And BC Packer says, OK, let me start, if it's metadata, opening metadata, creating a database. Same thing for headers. So I'm going to go all through them, going to create that. Now, while this is happening, at the start, Intellisense is not fully done yet. You can still do some stuff. You can see some stuff. Everything's not going to be ready until it happens that first time. That's just a one-time cost that you pay. When you add another include header, same thing is going to happen, except that everything else is already there. We're just going to be adding that new include header into the database. Interesting thing about the database is not just for Intellisense or what we call Intellisense in here. It's heavily used also for IDE scenarios. So, for example, navigate to, it's a new Dev10 feature. I don't know how many people are familiar with it. I don't know if you're familiar with it, but
navigate to.
Right. So, just small summary of what navigate to is. When you do a find, instead of finding based on text, let's say I'm searching for foo. I do Control F. My find window comes up. I'm going to look for foo. It's going to give me every single place, comments, etc., where the string foo is in there. If I just know I want to look for this function, I open navigate to, I type foo, it just takes me to the definition of those symbols instead of just text-based search. So that's a navigate to feature. That's fully based on the database. I'm just going to, this right here so that we can talk about it. When that happens, what happens is the IDE goes, hey, I need something. It asks a query to BC Package server, which is connected to the database. And then it goes back and say, OK, this is your list of stuff. And then it's a browsing and navigation feature. So if you want to navigate to it, it tells you what it is, and you go there.
Excellent.
So that's the interaction between the SDF, the IDE, and the front end at the same time. One thing very interesting is that the IDE and the front end, even though there are two separate components, they're two separate teams inside Microsoft right now. Also, they're kind of like, I don't know, brother and sister, if you want to call it that. They're really tight at the hip, so they share a lot of stuff, and that's why, even for customers, most of the browsing features are really Intellisense features for them.
Let's talk about where is the bottleneck here.
Right, so I'm going to give you one very interesting scenario, which is go to definition.
Go to definition.
Again, something you consider a browsing feature. But it's really, well, so we consider a browsing feature. Our customers consider an Intellisense feature. It doesn't really matter. It's just what the user uses, very important to them. So let me bring the front end back here. And this design actually changed a bit for Dev 11. So this is what customers in Dev 10 see. I do go to definition here. My request gets passed to the front end. Now in here, let's see we can resolve that, or there's multiple copies of it, or one of the multiples way where it can slow down. Let's just, for simplicity now, for the example, say that it couldn't resolve the signature correctly or found multiple of them. So what happens is this goes instantly, it gets here. Now when we go in here, it can't really resolve it, so it could do some sort of fallback. And now this takes forever because, well, it doesn't really know which one you're using, so it tries finding every one of them to give you real accuracy in there. Instead of just saying, hey, this is all, like, there's a text-based search, here's all the stuff that you have. So this is where that bottleneck is. Slight change that happened for Dev 11. So if I'm not mistaken, this is not completely out of the way, but we go to, from the IDE to BC Package server, we query the symbol first on the SDF file, which is fairly fast because it's just a database. One thing I didn't mention about this, some people know SDF files are just SQL databases. If you don't, now you know. We use SQL CE for building our database, and since it's a relational database, queries are fairly fast in there. So that's what gives us some speed in browsing features.
In Dev 11?
Or
in general?
This is used for Dev 10. Just this very specific go to definition example. Change a bit for Dev 11.
Which is great. You've kicked out a whole step.
So now, Well, we still have this as fallback, so if we can't find anything in the SDF, then we can go back and ask the front end for it. But first, let's go here, which is faster, and for the most part, it's usually accurate. There's always specific cases, what we call corner cases, where it might not be in there, and it might be faster to go to the front end, and it be more accurate. But for the most part, this is fairly accurate.
Sure, interesting. And now let's go to the example where dot or arrow, because you can do both.
Right.
Is in some sense there's a lot of latency, and to the extent where you might want to just not use it.
Right.
What are some of the causes of that, and where's the bottleneck in the picture you've drawn? Same story?
For the most part, yeah. I mean, this is fairly fast. Like, it seems like it's a lot because it's 2 layers in here, but this is just the editor was just grabbing your command, basically, your command, your keywords, whatever you're doing, the user input.
Yeah.
And then says, oh, this is the Visual Studio command, let's say, for dot, which we call member list. So let's say we do member list operation here. The editor just says, oh, this is a member list command, just process it, and then the VCAD goes, okay, this is a member list command, this is where I'm at, front end give you information on this and give you results. In this case, again, if it's slowed down at some point, it could be one of 2 things. One, and this is the most common scenario, we're having issues getting the data from the front end because, again, there could be a bug in the front end, or it could be that it's one of those constructs that doesn't really place too well. Or it could be, well, we got the data, but it's a lot of data. And we need to pass that up. And one good example of this is when you do, I have enough board here. So, using, probably I can't type right now, using STD. I think I'm going to have to use another color because this one is running out.
Here,
so
let's do blue.
hopefully blue shows up in there.
Yeah.
Okay, so
we got Michael behind the camera. He can do magic.
Yeah, worst case, we can go pick up a marker at someone else's office.
No, that's
so
great.
when we do this, this also brings up member list for STD. Now, people user know, STD has a massive amount of things in there. So let's say, for example, you're using one of the Visual Studio debug builds, which customers don't do, what we actually do. You can visually see a slowdown in there. And this is one of the more extreme cases because this is just massively huge. So this happens fairly fast. Now, problem is, okay, we go back. Here's a big list. There's a big list to the editor. And, of course, also the editor does, if they need to do some formatting or something, although in the member list specific case, not really that much. But, we're passing massive amounts of data from here all the way up to here. So it needs to be displayed for the user.
Sure.
And that's where the bottleneck might be in here. But for the most part, it's we're at the front end. We are asking for a construct, and it needs to get the data from that, which could be quick or could not. Most of the times, it's actually pretty quick.
Sure.
It's just this specific constructs, like we were mentioning. There's some cases where, well, we have some issues with them, either because we do have bugs in our compilers where we can't handle them that well, or it's just some really weird let's see, there's a very complex include graph in there. Things are split up into different places, so that could slow it down a bit too. So let's say we have a generic class. And this is a simple generic class, so we usually don't have issues with that. Now let's say you have class A that's generic, class B that's generic, class C that's generic, and you have something like A, B, C. So things are getting interesting because you got to do a lot of resolving. So for IntelliSense, we usually resolve these things. Example, a int, because when we want to display your tooltips and everything, you want to see your signature in there, rather than just a blob of. This is actually still simple. So you have something like 10 templates nested together.
Yeah, and that's your type.
Right. So you get you do QI here. Well, let's say you have this. Call this super complicated example that has, I don't know, that many in there. When you do your tooltip in there, that starts expanding, so you start seeing more and more and more and more.
Yeah.
So, okay, when do we stop? What is too much, what's actually useful and whatnot?
Sure.
So some people have different opinions on that. Some people say, just give me everything. Some people say, well, I don't really care about going all the way down. I just want You know, all the basic stuff, or maybe this.
Okay.
So that's where things start getting interesting. What do we display, what do not.
Sure.
It's more interesting for cases like quick info that I mentioned earlier, thing that has a tooltip rather than member list, for example. Because member list at the end, if I go here and do the members on this guy, it's going to be still a finite list. And you won't have something like, oh, there's a tooltip with, I don't know, 10, 15 lines of stuff. Because that's how much it expands to, which is, again, for some people they think it's useless. I'm one of them. Some people think that, well, you want all the information in there. Think sometimes too much is actually too much.
Sure, I agree. And in the case where you have these super long type names,
right,
it gets to be a little much, which is why I like aliasing.
So we go from the front end, we go down here. This is going to call C1XX, which is our compiler.
Okay.
Small mistake in there. CL, then C1XX, and then linker, etc., all the stuff that figures out to a build. When this is happening, this is not calling CL, this is calling the IDE compiler, so this goes a different route. Now, of course, the component still, this is cpfe.dll for anyone that actually cares about the component names.
I'm sure there are.
So this is cpfe.dll, and that redistributes here, but that's the common part. There's still how the parsing is done and all the different stuff, how the compilation is done is completely different between it. Not completely different, it's they use different compilers, so
sure.
The code paths are different. Okay. Let's say this is coming from header A, and this is header B, and there's bar in here. So if it's done doing this, so this may get colorized.
Okay.
Since it's not it's not finished doing this, this might still not know what it is. It could squiggle, colorize, etc., until it's done with the full parsing. Now, again, first time you pay the price of getting everything populated, and this is especially important for browsing, because the first time, hey, I'm doing navigate to what I mentioned earlier. I'm trying to do navigate to on this guy. Well, it's not there. The feature is going to work, but you're not going to get results from this until it's done. Now, there's a little icon on the taskbar that says Intellisense still going, and you also see in the status bar saying, now, this is where the size of your project actually comes in. The bigger it is, of course, the more things we have to do. But again, one-time cost. You pay for that once. Hey, I'm done. I close my project. I come in the next day. I open Visual Studio again. I load this. It's almost instant. Let's talk about colorization. That's one of the coolest features we did for Dev 11.
Cool. It's
available on the developer preview. If you haven't used it, you should.
I have, and I love the colors. They're very helpful.
Right, so it's kind of interesting because at the start, it was more like a rainbow, because we wanted to see how things are working. So we pull a little back on that. Now it's not that in your face. It's still there and customizable. Use one parameter for.
Okay.
So let's say this is my code, fairly simple code. What we had in Orcas and previously to that was, and even in Dev 10, so this gets colorized blue because it's a keyword, and I think that's in the example I just gave you, that's the only thing that will get colorized. Let's say I had a comment here. So this gets colorized in green, and this gets colorized in blue. That's what we had before. That's just basically based on the syntax rather than semantics. For Dev 11, so this still gets colorized. However, you can colorize functions, you can colorize parameters, sorry, not this, colorize the parameters. This is also a function. So all these things would colorize according to what you want. For a more interesting example, let's say, so we have a macro up here. I'm even going to write syntax right now just for simplicity. However, and since you mentioned, let's make a good one and a bad one.
That would be fun, though, to see. Hey, you forgot your number.
So if you do this, this is also invalid, right?
Yep.
And you do this. 5. So this one is invalid. So this will be squiggle, this will be squiggle, this will be good one. To close some colorization, though, so this is a function name, this is a function name, there's a macro, there's comments, this is a function parameter. So internally, all of this gets handled by and we know what each token is, and by tokens we mean, for simplicity, anything that's space delimited. It's not always like that. There's some constructs that have more than one, but just for simplicity right now, this is one token, this is another one, this is a token, this is a token, this is a token. So even this, if you really wanted to colorize your parentheses and semicolons and all that, you still could. I wouldn't recommend doing that, but you could if you wanted to. So once you have all those tokens, each one of them is customizable in Visual Studio, where you can say, oh, I want this in a different color, this in that color. So this is one other thing that got colorized in Def 10 as well. This is a string, so it got colorized red. It still gets colorized red. Comments still get colorized as green. Keywords still get colorized as blue. However, all the new stuff, so functions don't get colorized by default, but you can customize it. For example, let's say since we're on Christmas, you wanted to put a light green color in there. And for function parameters, you want to use, let's say, red, yeah, green and red for Christmas. So we have that. Then you will see this is a different color, this is a different color, this is a different color. And the cool thing about this is that it's right there in your face. You know what is what. So if I had a more complicated example where I had, let's erase all this. So you had, I define a class somewhere, and I do, let's call it my class. So since this is a class, this is already different. When I'm looking at things, I know, oh, this is actually a class. It's not like this. So this will look completely different to this. Like this is a keyword, this is a class. So I can know by just looking at it what things are. But actually saying, oh, what is this? So I can go to definition, I go all the way up there, figure what it is. Like, no, it's there, I can see what it is. While we're talking about this and moving up and down, one of the other, by the way, before moving on, this is one of those other features that I mentioned earlier that are fully dependent on the front end. So this is, it happens on the IDE layer, all the colorization happens in there. If you remember my diagram from earlier, this still asks the front end, oh, what token is this? So, because it needs to know, well, this is actually a class. And what I was mentioning earlier, if that's not parsed yet, then we'll not colorize. Once it gets parsed, you see colors in there, and it looks pretty. One other thing I wanted to mention for one of the other features we need for the developer preview was reference highlighting. So reference highlighting, it's fairly simple. So I have, let's say, another foo here, some code. So say there's like 100 lines of code in between. Well, let's be more realistic. There's like 10 lines of code in between, and this is all still on my screen. So when I put my cursor over here, this gets highlighted. And by highlighting, the background color changes. Instead of the foreground color, which is the way this is colorized, you see a highlight on top of all the usage of it. It's basically like invoking final reference of the token, except that it's there in your face. So if I'm refactoring something, or if I want to see how many things I want to change, or how many times I'm using this in this scope, like, well, there's all my uses right there in my face. I can just look at the second 1, 2, 3, okay, there they are.
Excellent.
So those are the two of the new features that we did for Dev 11. Both of them are fully dependent on the front end.
Sure.
Which is what we were talking about earlier, how the compiler is still there when you don't think it's there.
Well, I mean, if you think about it, like, you know, the editor, the IDE itself is a front end to what ultimately will be machine code. So it's interesting to see and over the years, clearly the compiler chain, you know, the tool chain has moved up further and further and further up the stack, which is great. So we essentially have this big compiler party now in the IDE. Before we do wrap up, I want to talk a little bit more about your daily experience, right? I mean, if you're the front end to the front end, man. You're working really closely with the IDE, and of course the developer's working on, you are a developer yourself, but you're really trying to break what they do and understand what they do and protect the end user from those experiences, make the product better. So talk to us a little bit about your daily routine.
Right, so one of the things we could start talking about there is, like you mentioned, so we're developers, we're not developers in the sense as we are fixing bugs, creating new features, etc. We really understand how the features work, and we make sure that they're not actually broken, that all the things that were supposed to work actually work, and the stuff that's not working, we tell people to go fix them. So one of the interesting part about that is that, well, you don't need to necessarily understand all the internals. Like you can C Intellisense. Let's go back to my small diagram here. So just for simplicity right now, I'm going to say this is a and this is the front end, and I'm doing memberless, for example, again. So at this point, I don't really need to understand how all this is done. All I really need to understand is that when I invoke memberless on, I don't have any class in here, but so when I invoke changes to PY too, actually, for this example. So when I mouse over here and I do a tooltip, what actually shows me in tooltip is the right thing. I could completely black box this as a QA, and I really need to understand how it works, or sorry, the internals of how they're doing things. I do need to understand the full stack. I do need to understand that this is calling this is where the information is coming from. This is how it shows up to the user, which is the most important part there, because if it works and it still shows up bad for the user, then what's the point?
Exactly.
So this is one of the things in there. But as I mentioned, you don't really need to black box. Most of us really understand our features. We understand the details of how they work. And sometimes that actually helps too, because, hey, I found a bug in here. I could go all the way down, debug it, figure out what it is. I could do a fix for it. I could, but the more information I get when I found an issue, the easier it is to fix and the faster it gets fixed.
That's the key.
Right. So sometimes it just helps knowing your features. Sometimes you don't really need to. Personally, I like to because I like to know my features. And we're all developers. We all like code. We are geeks in that way. So we want to see the code and we want to know what's wrong and what's working and whatnot.
Absolutely.
One of the other cool things in there is, like I said, even though we could black box this, so hey, what are the internals how that tooltip gets displayed? So I was mentioning earlier, there's an editor layer in here, and what really happens is that after all this information comes back, there's something that's a WPF window that has some text in there that displays this tooltip in there. So the more you know helps you where to test, knowing how to test, knowing at what layers you want to test. One really great example of this is, well, maybe when you're testing, if you just want to test the functionality and you want to test correctness, you do a lot of testing just at this layer, because all the up and down is not really going to give you much. It's going to be not necessarily that much lower, but you still have to pay the cost of, say, I'm running 4,000 tests, 5,000 tests. If I'm just calling this one component, it's going to be much faster, kind of a unit testing, rather than going through the whole layer. However, on top of that, I do also need to know that even if this is working, the tooltip for the user is going to be working. So got to understand the whole stack to know where and what are the right layers of doing testing in there.
Right on. Hey, great to meet you. Merry Christmas.